Hi, everyone. Good morning. We have the first session of the day. So this is a presentation that was designed originally for developers, but we're also presenting to DBAs because the intent of the presentation is to get developers and DBAs to work together and bring a more systems engineering approach to how to use Postgres, how to use databases, and of course, performance, right? So anyone here who does not like performance? Right? So as far as your users are concerned, faster computers, faster network, faster web browsers, faster databases are always a good thing, right? And one of the situations I found over about almost 15 years working in the Postgres community and talking to developers is that developers now love Postgres, but they don't really know what to do with it. And in every company, there's always a DBA team, and that's usually the team that says, no, you can't do this, you can't change this, and all that. And one of our intent for this talk is to kind of break that barrier and get developers to understand that Postgres is an essential part of their toolkit and how they can use it, and then how to also collaborate with the production people so that both teams can work well together, right? So first thing is a disclaimer. Both of us do it as a hobby, has nothing to do with our day job, so we don't represent our companies and all of that. So just keep that in mind. So people are still entering, so it's a good time to ask the question, right? Like, why are you here at the Postgres conference, right? Hopefully you want to learn. You want to learn more about Postgres, but you also want to learn more about other ideas on how to use Postgres in different ways, you know? So if you're a developer, or if you're an architect, or if you're a DBA, you have a comfort zone, right? And usually DBAs go to database conferences, and developers go to developer conferences, and they don't get to talk to each other, right? So how many people here actually do databases and development? Okay, that's good, quite a few, right? And how many people who just work with databases, just do DBA work? Okay, that's a good mix. Anyways, this is a bit of an experimental talk, and what we wanted to do is to show you some ideas we were working on, and then some tools that we built, right? Don't take any screenshots. Everything is available on GitHub. We'll show you the link at the end. And what we want to do is to encourage collaboration and contributions. You can use the code that we have developed and the tools. Use it, give us feedback on how to make it better. And also there's a potential for you to give us some code that we could use to run as part of the experiments and show you how to improve performance, right? So the first talk I gave was about, in January, I gave it to the Python group and to explain to them again, you know, how to use Postgres inside the database. It's a very high-level talk, but then Anup was going to take over some of the more technicalities. The original story started about a few years ago. Unfortunately, I didn't capture the tweet that I saw, but it was really interesting. Someone well-known in the Postgres community tweeted saying, I joined this new startup. They're actually 2 years old, and they're using Postgres, but they've never had a DBA, right? So if you're running Postgres in RDS or any managed service, you don't, for the first year and a half, you don't really need that much till you really start growing. That's when then you need a Postgres expert to come and help you and understand how to improve your system. Then 6 months later, he tweeted saying, hey, I've been working with this application group in the startup, and we made some interesting changes. I forget the exact number, but he said something like, we reduced 20,000 lines of code from the application and replaced it with about 2,000 lines of code of Postgres. And now the application is running 50% faster, okay? Now that's what a DBA can do with an application team. That's why that relationship is really important. So I was thinking like, okay, can we replicate something like that and figure out what are the steps and show people how to do this, you know, and also find a way of measuring things, just doing some experiments, and that's how this talk sort of came about. So First, we need to talk about platform, right? So I had a presentation I used to give when I was working at a company before. And I always get into a conversation is that why is Postgres better than any other database, right? So my first thesis is that Postgres is not a database. Then you eliminate the question about is MySQL better, or SQLite is better, or MongoDB is better, and all that. You should look at Postgres as a platform that can allow you to do a lot of things, including data management, right? Then you change the perspective. And one way also I like to present Postgres is that it's like an operating system. Just like Linux has a kernel, right? And to make changes in the Linux kernel requires a very high bar of code quality. But all the applications you run on top of the kernel will never, hopefully not crash your system, but it allows you more flexibility to do things. And Postgres has that same model that people don't really appreciate, So the Postgres open source that you get, think of it like an operating system, and everything else that you do on top of it is like your user space application, right? So now thinking about a platform, the most important thing you have to know in distributed systems and systems architecture is what happens with your network, right? Because all the systems are distributed over multiple computers, and they have to talk to each other. And even though network looks like it's free, there's still a law of physics, right? There is going to be some latency between the systems, and you need to understand that when you're building and designing your system. So if you Google it, you'll find this kind of thing. Apparently for Google engineers, they almost have to memorize these numbers, right? What is the latency for different levels, right? Whether you're doing an algorithm that works at the chip level, does it work at the memory level, does it work at the cache level, does it work on the network, right? And look at that last thing, right? It says, sorry, I can't read from here, but going from data center to data center, right, 150 milliseconds, right? And network is always going to be slower than what you can do inside a system. And there are new systems that actually are starting to change that equation, but we're not going to talk about that today. So let's go to the next thing, like what does a traditional application look like, right? Let's say we're using Python. Python is one of the most popular languages, and is going to connect to a Postgres database over the network and talk to it, right? So what does the code look like? First, you have to establish a connection to another machine where the database is running. This is approximately, you need the password and the port number and all of that. And then you create a SQL query, you execute it, and then you close the connection. That's how your traditional applications work, right? So again, remember, right? If you look at the bottom few, you'll see a factor of 10 difference in terms of the latency and the round trip figures. This is kind of what your application structure usually looks like, right? The most complex one is the one on my left there, So there are many layers, and you can see the arrows, and you can see where most of the latency is being held, and the databases are at the end. So what tends to happen is that these are the different layers, right? You have your front-end code, and then you have your middleware, which is a green, and then you have databases, which is a blue. And what tends to happen because of performance reasons, and you're scaling your application, and you're going from 1,000 users to 10,000 monthly users, and then maybe even hitting 1 million users, Postgres is not a distributed database, so it's designed to run on one system mostly. So you're going to throw a lot of hardware at the database layer, right? And that's going to be the most expensive component that you have. But if you really think about your system design and try to make it more efficient, you can actually move the complexity to different layers, and you will see a change in the behavior of the application. So what you can do is that take your Python code, which is sitting there and feeding the web server, right? That's the front end that the users see. You can actually take it and move it to the database layer, because again, Postgres is a platform, right? It's a platform that sits on top of an operating system, and you can embed code in it. And that model is called PL, right? It's a programming language, right? So Postgres doesn't just run SQL. It can also run structured languages. So there's a PL/PG SQL, which is a structured language. Then there are PL Python, PL Java, PL Bash, PL Perl, and there's about probably like, yeah, we said about, I think 30 different languages there. Some are experimental, some are well-known that have been there for 20, 30 years. So back to what's the platform about, right? We want to move the compute closer to the data, right? And when the compute moves across multiple layers of the network, you'll end up with a factor of 10 improvement. When your compute is more efficient, you end up using less compute. That's what's happened, right? So that has two benefits. One, either that as you scale concurrency, you don't need bigger machines, or you don't need more machines. Okay, that's an important factor you should take into account.
Okay, so hello everyone. So now I will talk about Postgres extension. So before that, I will just share my journey. So I started as an embedded developer. I primarily work at Linux kernel, even doing some of the open source contribution. So how I see the Postgres extension is like we have a kernel, and at the top of that, we have the application running. So similarly, we have Postgres, and then you can write various extensions which will increase its functionality, and you can do lots of things out of it, right? And as Mehboob already stated, that we have many languages in which you can write a Postgres extension to improve the support. So one of the famous language that we have is Python. It is widely popular. So in case you are coming from some background where you have been writing Python application code, you can simply go ahead and write your code in PL Python, and that will get executed inside your Postgres system. So in the beginning, we saw a F1 car, right? So we all love having a system which is very fast enough. But only having a system which is fast or which is high performant is not a good idea. We should also go with safety and efficiency, right? Because lots of things can go wrong in a picosecond. And if just taking an example of a car, if we don't cross the end line in time, then due to some crash or something, then it's a disaster, right? So that's where Rust comes into play. So I have been programming in C and C++. So I have been recently introduced to Rust, and one of the major difference that I see is when we program using C or C++, it gives more flexibility to the user. The user can do lots of things, but Rust expect you to write better code at the compilation level only, and it will throw errors if we are not handling memory properly. And it has some of the magical things like cargo, which is a very great build system to take care of your dependencies and all. So yeah, that's what we have, PL Rust. So we can write our extension in Rust. So that's what I explored now we will explore during this presentation. So to write the PL Rust, I have been using PGRX. So I found this is an interesting framework for the Postgres. So what the PGRX does is, it exposes the PostgreSQL C APIs into the safer Rust. So Rust has two versions. One is safe and unsafe Rust. So if you write the Rust code in a safe way, then basically it removes many opportunity of crashes and the corruptions. And as Rust is a compile time language, so the performance that you get is as close as C, and it's run pretty fast than other dynamic language. So now how to use PGRX, right? So these are some of the commands that you can try to create a new extension. And then the best thing is it will just create the schema and the template for you. You just need to go and write your functions in Rust. And you can test it using the commands, and you can even create a package for your extension. So some of the major benefit that PGRX offers are like, it supports from Postgres 12 to Postgres 17, so that once you write your extension, you can test it on different versions and check how it is performing. And some of the safety features that it offers are like, it translates the Rust panic into Postgres error, so that it will abort the transaction and not the entire process that's Postgres. Yeah, so now let's talk about some of the benchmarking that we have done and the results for it. So we have, yeah, so we have used this open source tool known as Faker.js. So it's just to simulate and create some data. So what we are doing here is we are creating 1 million transaction where we have a user ID, unique ID, then the name, then we have the email ID, the amount, and then the payment status and those kind of things. So once you generate the data, this is how the data look like. And yeah, so now we have open source all our work that we have done in the FastRx. I will share the GitHub link in the end. So we have all the files like setup, like this is just a demo of the setup file. So as you can see here, like before, so what you need to do is just you need to clone the repo and just run the setup file. It will do all sort of checks, whether the Postgres is installed or not, which version is running, and if it is not installed, then we have some other lines of code to install the latest version. And then once it set up the Postgres database, it will create a database known as test transaction, and it will insert the schema, and it will load the transaction file. So we tried an experiment where we ran this, we calculated the moving average. So moving average is like, suppose if I have 7 days data and I calculate the average of it, and when the 8th day comes, then I will calculate from the 2nd to 8th day. So basically, the window size will be the same, and it has been widely used in the financial industry. And also, I heard that it is used for the weather forecasting and even in the IoT industry as well. So you can see here the time taken for doing the computations was somewhere around 1.8 seconds. And when I did the same thing over the network, that is been from my system to the server where the Postgres is running, it took somewhere around 12 seconds, right? So yeah, we thought like it's majorly due to the network that we are seeing this latency, but there is something more which we will discuss. So now to understand, right, why it takes 12 seconds, I use this tool, perf tool, and it's a pretty famous tool. As I said earlier that I come from a kernel background, so I was trying to see whether the profiling that we do for the kernel level, can we leverage those things in the Postgres ecosystem or not, right? So I think many of you might be aware of this perf record command as well. So what it does is it does the system level profiling of whatever the command that you are running, and it will generate a binary file known as perf.data. So now, interestingly, Firefox has a very interesting, again, profiling project known as Firefox Profiler. You can just go to any browser and search Firefox Profiler, and it is widely used for doing web app performance analysis. So it gives us a good UI. It's a basically time-based, based on time, where the system calls are taking times, what is the network latency, you can view all those things into this profiler. So in 2023, I participated in Google Summer of Code program where I added this Gecko converter. So the format that the Firefox profiler support is known as Gecko. So my patch or my contribution to the Linux kernel was basically aiding a support to convert the perf.data file into a gecko.profiler JSON file, which Firefox profiler understand, so that we can leverage the Firefox profiler to see the system profiling as well. So what you can do is you can just run this command. So perf script report gecko. So what it will do is once your perf.data file is generated, it will open your browser and it will show you the visual of it, right? And also it has some command line arguments like save only if you just want to save the file and don't want to open it in the browser. And it will also capture like whatever it has captured, it will save it in a JSON file. And this is how you can go to the Firefox profiler website and you can load profiler from file. They have a manual option to load it. And once you load it, you will get something like this. So here you can see in this 12-second window, like where is the bottleneck, which is taking how much time, we will be able to understand through this. So the yellow lines that you can see, or the yellow color one, are the time that is spent on while doing the user space level system calls. And the orange one are the one which is happening at the kernel level, right? So majorly we have seen that. So the orange one is basically for the network latencies. And the yellow one that you see is, now what is happening is Python is a dynamic type language, right? So it's an interpreter, so it executes the code line by line, and it needs to, instance the memory and then, check the types of the variable and do all those kind of things. So we can see the major latency is coming from, again, from the Python, right, here also. So that's what, so initially developing, any extension in Python seems easier, but over the time when you have some production ready code, then you see, what's the cost that you need to bear if you use such kind of, if you use Python as a language. So, yeah, and then we also try to do the same thing, the moving average thing in PL Python, right? So this is for calculating the moving average. And we try to do the same thing in Rust as well. So, and for the comparison, like we got that, the difference was not so big. So one of the reason here is we are just simulating this with 1 million transaction. And so when we will go with, more complex algorithms, or when the records will be much higher, then this numbers won't get add up, but this will get multiplied, right? So that's where we will see the difference. So choosing the right language for the database level can make your queries X time faster, leading to huge efficiency gain at scale. So yeah, by this just a simple conclusion is that, performance is a feature. So we should treat performance as a black box whenever we are doing the software development. And we should always use profiling tool at the beginning of the development, so that to understand where the time is spending. Just in our case, we have seen, we thought it's due to the network latency. No doubt, network latency was contributing one of the major factor, but there is more thing to do with the Python itself. So, yeah, and that's what, like, never accept that we will fix performance at the end of the project, and it's never work out. So this is the famous saying that, if you want to improve something, then you must do the measure, right? And measuring what really matters is the key. So, and here are the references. In case you want to know more about PGRX, you can check out this talk in YouTube. Yeah.
So one of the important things is that Rust is fairly new, but it is almost, I would say it's close to 10 years old now. Originally, it started out as a project inside Firefox, inside Mozilla, as a way of rebooting the whole Firefox code base and rewriting everything from C to something else, right? And the problem always is that C is a flexible language, but is also a little bit unsafe, and it's very easy for you to, foot gun yourself, right? Shoot yourself in the foot. And, a lot of operating systems, large systems are written in C. There's a huge code base. But things like Windows, not Linux as much, but mostly Windows has always had a problem of unsafe code, and then you end up with viruses and malware and all of that. So Rust has become so popular now that Microsoft is rewriting a lot of their low-level drivers in Rust because it promises that safety, right? So Amazon, AWS, for instance, they created their own hypervisor called Firecracker. Is written in Rust. Google is using Rust. Oracle is using Rust. Rust is now also entering the Linux kernel. Yeah, there was a big fight about it. Some developers didn't like it, and they got into a fight with Linus. He said, this is what the future is going to be like. Just get ready for it. The Postgres, as a core code, has been around for 30 or 40 years, and it's all C. It's never going to be rewritten in anything else, right? But being able to write the extensions in Rust gives you a way to experiment with things without having to change the core code, right? Again, treat Postgres as like a kernel, like an operating system kernel. And Rust gives you a very flexible way of adding functionality on top of that kernel, and that's one of the reasons why we decided to start learning Rust. So the other interesting project also came out from AWS is that when you're running Postgres inside RDS, the only extensions you are allowed to use are the ones that are already in the RDS catalog that have been whitelisted, right? And one of the ways that you qualify an extension is that the way the AWS team told me one time is that we assume that the people who designed the extension have dropped it. It has to be open source, and we assume that someone has dropped ownership of it. The way they treat it is that if the original developer has stopped working on the extension, and you are using it in AWS or in RDS, when you need to upgrade to the next version, you're going to get stuck because this is suddenly not supported, right? So the catalog of extensions is quite extensive, but also very strict. But recently, a couple years ago, AWS came out with a new concept of saying, if you build an extension using a safe language, we will allow you to install it directly into your RDS environment without having to whitelist it, right? So if you're a corporation and you want to standardize some code, you don't want to have to open source that code and beg AWS to whitelist it so that you can use it in your own database, right? So this is a very interesting model, and I'm hoping more of the hyper cloud companies adopt that model. So by the way, so Python is not considered to be a safe language as far as extensions are concerned. But if you write your extensions in Rust, it's considered to be a safe thing, right? So one of the things that we want to do, and all the code is here on the GitHub, and this is an experiment. We're working on different things. What we want people to do is to be able to go to the GitHub, fork it, try it yourself. And if you have some interesting algorithms that are maybe written in Python and you're wondering what the Rust version looks like, we'd be interested in converting that code and doing some benchmarking with it. One of the things that we did with the benchmark, we ran into some problems with Hessner where they blacklisted our servers, So, but one of the things that we wanted to do is to first build the algorithms and test them individually, and then run them like, simulating 1,000 users or 10,000 users, right? And then see what the difference is between running a Python version and a Rust version, So that's some of the things that we're working on. So what else do we have? So this is an interesting new product that came out recently. This is actually Michael Stonebreaker's latest project, right? So Dr. Stonebreaker originally started Postgres in Berkeley many years ago. And what they said is that let's treat the database as an operating system, which is, again, the same concept that we were working on, but they decided to make a product out of it. So what they were able to do is embed all the things that you would use different AWS services like Lambda and all of that, but executing them all inside Postgres. And a lot of this is open source, and they're supporting 2 languages right now. One is Python, and the other one is TypeScript. So you can program inside a Postgres environment as if it's the full operating system, but the benefits you get are really tremendous, So I would it's called DBOS, Database as an OS. You should definitely check it out. A lot of it is open source. Their product is the cloud version, of course, that's their paid product. But this took the same example that we were working on and actually decided to make it into our product. And what this also does is that it has an embedded Postgres instance inside its own, and then it can also talk outside to a database that you already have, so you don't have to migrate your database in. Very, very cool project. I'm keeping an eye on it. Then the other thing we're interested in is that I'm also working on a community conference in Ibiza. So it started out as a small Postgres conference, but we're trying to build it. There's way too many conferences. I can't go to all of them. But we're trying to build a new conference that's based on systems engineering, right? So we want to bring developers and SREs and DBAs together and talk about how to do a complete tech stack based on open source databases, Postgres specifically. So the 3 tracks will be systems engineering, security engineering, and distributed systems. And this is something that we're trying to build out. We started originally in 2019, and then COVID happened, so we canceled for a few years, and now we're building it again. Hopefully, you should check it out. And the last thing is that, that's why we want to talk about modern platforms where the database is not a black box, but is part of your toolkit. And that's something that we want to educate developers so that they understand that databases are something that they should really master and not treat it as an afterthought. So any questions we can take, we're happy to. Hope you enjoyed the talk.
So you said that the Python is an untrusted language, right? And PL Rust is considered a safe language in the database, right? So can you please elaborate what are differences between like Python and Rust? They are all like system language. You can do harmful things. How is it different? How can we treat PL Rust as a safe language?
Right. So so Rust itself has some capabilities. I'll have Anup talk about it a little bit. The PL Rust version of it, I think, allows you to restrict certain operations that you can't do on the Python side, right? And specifically on the Python side, you can access a lot of systems. You can access the file systems. That is forbidden in an extension, right? So if you have an extension running in RDS, there are certain things you're not supposed to do, you know. So recently, I remember Wiz Systems found a problem with Google's GCP version of Postgres and also AWS, that if you are able to hack into the system, you are able to see every single tenant running on that DBAS, you know? So problems like that, because Postgres was not designed to run in the cloud, it allows you to do almost everything. Python allows you to do everything also. Those things have to be curtailed, you know?
So you're trying to say that PL Rust has limited standard libraries, so it cannot access some system functions.
Yeah, things are limited, and also the PGRX makes it easy to do certain types of things that you would want to, but in a safe way.
Thank you.
Yeah, thank you. Hi, Jobin.
And first of all, thank you very much for calling out that network delay is something seriously hurting, because in my day-to-day work, I analyze at least 5 to 10 systems, and I see this. The network is the major bottleneck, emerging bottleneck in modern systems. Thank you for that. And my question is about the profiler which you developed. Yeah. So is it completely open source?
Yeah, it's completely open source, and the code are already available on Linux 6.5.
Okay, 6.5.
If you have Linux kernel 6.5, you can still use it.
Oh, okay. So only from 6.5 it's.
Yes, this support for this gecko. So that command that I have added and the converter.
Okay.
Perf is already there, but if you want to use that converter, then you need to be on the 6.5.
Okay. Nice job. Thank you.
Hi. Nice talk. We discussed something said like database as an operating system. There was some slide mentioned like that, database as an operating system right now, like nowadays it's going. So I wanted to, like, can you give us some examples? What are the benefits, like sharing some examples of using database as an operating system?
Are you referring to this? Yeah. So this is a product. I don't work with them. I'm just aware of them, and they've written a lot of papers and all that, right? So again, what they have done is that they're treating the database as the primary platform, right? Because the database talks to the operating system, it talks to the hardware, it handles storage for you, and it also handles networking, right? So if you use all the rich libraries that Postgres has, because Postgres does some really crazy things, like it can read from an SMTP server, it can send email, it can call out to shell, you know, it does some really wild things that databases are not supposed to do, right? But so the idea is that if the database virtualizes what the underlying operating system is, then your code is more portable, because it's just talking to whatever it knows right there, right? And it doesn't have any dependencies outside, right? So if you look at the original example, which is Stripe, talking to 7 or 8 different services, right? When you run that at scale, you'll see the AWS bill come, and it can be quite shocking for people, right? And there's so many dependencies, and that makes it impossible for you to move your application to another cloud environment, right? So what does an operating system do? It protects you from the underlying infrastructure. And if you have something like Linux or even Mac OS or something, you can run in multiple systems, and you don't have to worry about what the underlying hardware looks like. That's what an operating system does. So Postgres is doing the same thing. You can run it on even Solaris, you can run it on AIX, you can run it on HPUX, you can run it on Linux, Mac OS, Windows, right? But the code that you write inside it is protected from the dependencies, right? I remember the first time when Microsoft came up with their first version of managed Postgres, the 1.0, they ran it on Windows. And that was a huge mistake because they found out about 75% of the Postgres extensions depended on Linux, right? So all of those things were not available. So then they had to retrench the engineering, and the second version is now based on Linux, right? So that's the important thing, right? What is the dependency? Like Peter said in his keynote, what is the lock-in, you know? And Postgres being a portable layer, now running on top of Kubernetes, which is also an interesting platform, it protects all the code that you write from dependencies on the outside. And that's the model that they wanted to use. Because they saw like the most complexities was that when you unbundle all these different things you need to do, and you depend on outside services. And then when you need to debug, you need to go to 5 different places and do tracing and monitoring. All of that has become a whole new, you know, cottage industry, how to debug distributed systems, right? So if you live in a protected environment, your surface for troubleshooting is much less. So that's the whole concept. Thanks.
Hello, sir.
Yes.
I have a question. How do these language options influence your query execution plans or parallelism in the context of PostgreSQL?
Right. Yeah. So Postgres architecture is a process-based system, right? So that's already built into there. And all these PL languages, they actually exist as extensions themselves also. So you can say create extension PL Java, and then it will load and attach all the code required to talk to the Java JVM. But everything that happens in computationally still happens inside Postgres' space. So that is just part of the architecture. You don't get all the flexibility of everything you might want to do in a specific language, but as far as databases are concerned, you have direct access to the execution engine, and you can get some optimizations that way. And because you're not going outside the process or not going to another server or across the network, you get much more, you know, better performance, immediate execution, right? One of the models I will bring up that is no longer fashionable is that was all the Hadoop thing, right? If you had 1,000 servers and your data was spread out over all the 1,000 and you wanted to do a computation, you had to send that script, whatever you wrote, to 1,000 machines, right? And that was the MapReduce system that Google had built, you know, 10 years ago. And that's how Hadoop came about, right? Postgres can actually do something similar because it knows how to run the code inside at the database level itself. So that built-in distribution capability is there, but again, if you treat it like an operating system, the concurrency and everything comes for free because databases are designed to be, you know, run with multiple connections, multiple users. So the concepts are all there. You as a developer shouldn't have to worry about the complexity. That's the key message that we want to give.
Okay, thank you.
Right. Hope that answers the question. Thank you.
Yeah.
Okay, just a follow-up question related to DBOS. Like we also have Supabase, which is like open source and allows login system based on the Postgres and other stuffs which are strictly related to Postgres. We are not dependent on anything, and I think it's deployable everywhere. So is it similar like DBOS, or like Supabase is the implementation of DBOS or something?
Right. So it is not. DBOS is a very brand new idea, right? Supabase is a more traditional system. What they have done is that they have made it easier to use Postgres. By the way, just for transparency, Supabase acquired the startup I was running. So my engineers and CTO are now working at Supabase, right? It's a project called OrioleDB. I gave a lightning talk last year about it. What Supabase does is that because they started out as JavaScript developers, they just wanted to make Postgres easier to use and build layers on top of it. What they're not doing is allowing you to build the code inside of Postgres. They're still dealing with Postgres as a standalone database. And what DBOS is doing is something radically different, is to bring all the execution environments inside Postgres and not layered on top. That's a distinction. Okay, hope that answers your question.
Yeah, thanks.
Okay, well, thank you everyone. I hope you found this interesting, but please go to the GitHub. We're happy to get feedback if you run the code yourself. You have some interesting code that you want to benchmark. We want to learn more about this and do some experiments in converting Python to Rust and testing it. We look forward to your contributions. Thank you, everyone. Thank you, Anup.